It's a cultural opportunity for students and the community to explore the rich heritage of St. Bernard as Nunez Community College and Penn TV presents the Nunez History Lecture Series.
Welcome to the Nunez Historical Lecture Series. This is going to be a lecture about Hurricane Betsy and also the associated hurricanes that have come through the North Atlantic. My name is Paul Trotter. I'm the meteorologist in charge of the National Weather Service Forecast Office, New Orleans, Baton Rouge, here in Louisiana. First of all, I'd like to point you to our screen here just to give you a little bit of background about the hurricanes and the hazards. Associated with hurricanes are tornadoes, storm surge, heavy rain, flooding, and wind. But if you look at the spaghettiness of the graphic, you'll see that since 1886 to the year 2000, we've had 1,013 storms. And if you've noticed, in our area, they're quite common. Let me give you a little bit of overview about what we'll be talking about relative to Hurricane Gumbo. There's a lot of mixtures that goes into hurricanes. We have the El Nino and La Nina phenomenon. We have a Southeast Louisiana Hurricane Task Force that comes together and plans and prepares everyone, different agencies, federal government, etc., to get together and do what they have to do relative to preparation for hurricanes. Tropical Storm Allison, we're going to talk a little bit about that. We're going to talk a little bit about Tropical Storm Bertha. We're going to talk about our landscape, what we look like as far as the terrain, rivers, etc. Also, we're going to talk about slosh, and I'll give you the definition of that in a second. Offense and defense. Offense meaning, what you can do in order to prepare. Defense means that, hey, I don't want to lose. In other words, I don't want to lose my life, so I better take immediate action. We're going to talk a little bit about forecast errors and end up, hopefully, giving you a little exercise. Well, let's look at Homeland Security. Homeland Security is very, very important. That's the hot topic that we've been going through here. Landfalling hurricanes are a sense of your Homeland Security, so you have to make sure that you get yourself prepared relative to hurricanes in general. Now, let's look at what's happened with our president. Our president feels so passionate about hurricanes that he announced a National Hurricane Week. And if you notice, there's on the graphic itself, from Sunday through Saturday, there were a lot of activities from May 19th through the 25th relative to hurricanes, talking about history, some hazards, preparatory notes, etc. These are the type of things that we're really involved with during the hurricane season and preparation. So we've done that early portion of this year. Our next graphic demonstrates the El Nino and La Nina phenomenon. On the top, you'll see that the El Nino phenomena is on the top portion of the scale, and below that scale is your La Nina phenomena. Hot and cold waters are the definition relative to the El Ninos off the area of Peru and the Pacific. If you notice, the red gives you various frequency of the El Nino phenomena versus the blue gives you various issues relative to the La Nina phenomena. Now, it doesn't matter how many storms you have, it's the one that hits you. In the El Nino years, normally there's less storms than you have in the La Nina years. Here's an example of that. The La Nina phenomenon, you have the blue, colder waters in the Pacific, and the El Nino, you have the warmer red phenomena water in the Pacific region. And what happens with that is that it varies the jet stream. When you have the El Nino year, we have a strong jet stream that crosses the lower latitudes and it deters the storm formation. Now, in our area, we're very, very I guess you could say, not blessed relative to our terrain. Very, very low terrain. Folks, you should know your elevation, because if you don't know your elevation, you don't know how to respond. There's a lot of levees, there's a lot of rivers. The bathymetry, which means the depth of the water in the ocean near our area, is very, very shallow. So as far as storm surge, when storm surges come our way, it doesn't have any place to go. Plus the low terrain, the fact that we do not have any elevations, you don't have anything that really can go ahead and stop the storm forces that come toward our area. The Southeast Louisiana Hurricane Task Force has come together to go ahead and generate some studies focusing on hurricane hazards, vulnerability related to hurricane hazards, behavioral analysis, what you do, how you respond, shelter analysis, where the shelters are in case there is a storm, transportation issues, and also the coordination. That's one of the reasons why we meet so often during the year. Now, and I talked about some hazards earlier. One of the greater hazard is the wind. Now, the wind in general gives us our various classifications. What you want to do is not be impacted by the wind, so you should seek safe haven. Make sure that you're taken care of. Another issue is tropical storms. Last year we had tropical storm Allison, and it really gave us a lot of devastating rainfall. Let me give you an example of what I'm talking about here. This is Houston before the storm. This is Houston after the storm. Very, very significant flooding. There's Houston before, areas of Houston after. Houston before, areas of Houston after. This is very, very significant. This gives you an example of the impact of the heavier rains. Now, what do you do to combat those? The only thing you have to do is really try to avoid the areas that you have a lot of rain and a lot of flooding. And that's very, very difficult when you're talking about tropical storms or hurricanes. Here you have Tropical Storm Bertha. This happened earlier in the year. Landfall, this is a satellite photo giving you an illustration of how Bertha looked as it approached our particular area. Bertha didn't have a tremendous impact on us, but it still gave us a sense of a little preparedness on the early storms that we normally have. If you notice, this is an infrared shot of Bertha. This gives you an idea where the heavier rains, if you notice, over in the Florida Panhandle and also in Alabama is where the more significant rains were occurring as the storm approached. But then later on, our radar photo shows what happens in Washington and St. Tammany Parish, where you did have a lot of heavy rains associated, 5 to 10 inches of rain associated with that tropical storm, much less than Tropical Storm Allison itself. If you look ahead and look at our particular area here in Louisiana, you can see this satellite photo gives you a demonstration of how the New Orleans area sits and how St. Bernard sits relative to the open ocean. Very, very unforgiving as far as location. There is one thing that we try to do to combat the hurricane issue, and as far as our shallow nature, it's a levee system that's built around our area to try to protect us relative to any type of storm surge around the St. Bernard area in particular. But due to our shallow surf and our low terrain, you can see that we have influence of Lake Bourne, Lake Pontchartrain, and then the open waters, and also the Mississippi River. Various bayous and all inlets and all that makes transportation issues very, very complicated for folks to try to get out of harm's way. The metropolitan area in general of New Orleans is very, very significant in the fact that you have currently about a population of about 1.5 million people surrounded by water with limited evacuation routes and over 50,000 residents without transportation in general. That really causes some problems. This is Hurricane Betsy in 1965. Now, if you look at the bridge, and over on the right side, this point here is where water is trying to be pumped out of some of the canals, right back here, into the industrial canal in order for us to go ahead and be a little bit more comfortable. That's very, very significant because once water gets in, the only way that it's going to get out is normally through a pumping system. And then where are you pumping it to? Are you pumping it into the canals, or are you pumping it into the lakes, or are you pumping it into the river to try to get the water out of harm's way? I talked earlier about what we call a sea lake overland surge from hurricanes, commonly known as slosh. I repeat, sea lake overland surge from hurricanes. That's what slosh stands for. It's a two-dimensional mathematical model used by the National Weather Service to try to calculate the potential surge heights of the storm-related water. So water didn't have in the open ocean. Normally you'd have water transporting energy down into the lower depths. But due to our bathymetry is so shallow, it doesn't have an opportunity to go ahead and go into the lower depths. It just builds up higher and higher and higher. That's why we're so vulnerable. Hence, we have to have levees to go ahead and protect us. The storm surge in general, the slosh model, results in a time history of wind and surge. Therefore, the slosh model is run for specific coastal basins. In Lake Pontchartrain in general, our basin, we have 9 storm track directions: northwest, northeast, southwest, south. All these directions are placed into a compass. We have 3 forward speeds of 5, 15, and 25 miles an hour, between 17 and 20 landfall locations for each storm direction, 5 categories of storm intensity from Category 1 through Category 5, and 2 tidal conditions, either high or low tide, but normally you should focus on the high tide. And you have a total of about over 5,000 storms that are run, hypothetical storms. It gives us some information. As you can see on this particular graphic that we're coming up next, this is a fast-moving Category 3 storm headed towards St. Bernard. And as you can notice, if you look at some of the flags in the lower portion of the parish, and then Plaquemine Parish is 9.0 as far as that flag, will give you an idea of what happens with the storm surge. Note that the right front quadrant is the favorable areas for all your conditions to be coming together as far as wind and storm surge. If you have a northwesterly moving storm, if it's moving quite fast and in Category 3, you can see the inundation and the coloration. However, if you go to the next slow moving storm, there's significant changes. Now I'll flip back and forth so that you get an idea of these 2 storms. One where you have a dry condition, other locations, one where you have a wet condition. We go back where you're kind of dry, in particular in the New Orleans area, but if you go forward with a slower moving storm, you get inundation. So that's a problem with storms in general. Now, this particular graphic gives you an idea of what I talked about knowing your elevation. Very, very important to know your elevation. Take, for instance, if you are living on a 10-foot elevation above sea level and you have a storm surge of 15 feet, that means that you'll have to contend with 5 feet of water that's above the 10-foot elevation. So that gives you an idea of what you're contend with. If you're 6 foot tall, your head will be above it. But if you're 5 foot tall, your head will be below it. Very, very important to know your elevation so you can know how high you have to get up to get out of harm's way. New Orleans in general is always noted to be in the bowl. You have levees on the lakeside and you have levees on the riverside. The river levees are much higher than the lake levees, and that's sort of known as your high ground. If you look at the photo from A to B, you'll notice that's about a 5-mile segment down Canal Street. You'll notice that one of the higher points is Gentilly Ridge, and that's only about 4 or 5 feet. Everything else is either below sea level or either sloping to be above sea level. So that's the contention. Once water's in, where's it going to go? Where are you going to pump it out to? That's very, very significant to know your elevation and to know the problems related. Now, this gives you an idea of what I'm talking about. Let's talk about vertical evacuation. Here it is. You're at St. Louis Cathedral on a nice bright day. Now, vertical refuge. Well, let's look at it. Residents at risk of storm inundation in southeast Louisiana is about 1.15 million people. Residents without transportation, as I stated before, 50,000. Estimated clearing time for storms up to about 50 hours ahead of the storm. Most designated shelters are located in central and northern Louisiana or in Mississippi. Hurricane Georges in 1998, we had 14,000 people taking residence in the Superdome. Very, very, very important to know your elevation. Now let's look at that same St. Louis Cathedral and think about the heights related to it. Now, you see where the horse was earlier? Now you can see where the horse is now relative to the water. That's what we're talking about as far as vertical evacuation, to know that you got to get above the water, but you still will be suspect to the significant winds. Winds, as you go up in elevation, increase, and we found that out relative to drop wind signs, and I'll talk a little bit about that when I talk about the aircrafts, into the storms. We find just above the surface the winds are going much faster than you would anticipate relative to the storm. Now, this particular graphic gives you a demonstration of a reconnaissance flight path, how the reconnaissance planes go into storms. This is called an alpha pattern. They go into storms and take various measurements. Now, we have a new aircraft right now called the Gulfstream aircraft, NOAA Gulf 4 aircraft. We just had this about 4 or 5 years riding into the storms and around the storms. This gives us the nature of the storm. It drops this instrument, as you can see, into the storm, taking various measurements of the storm character. It measures humidity, it measures wind, it measures pressure, and gives us feedback and lets us know what the storm is doing as far as character. Now, associated with this particular aircraft, there are many more aircrafts. We have a joint program with NASA and also with the Defense Department, whereas you have the Air Force. The Air Force C-130s are the primary workhorses. They are the ones that go into the storms more so than any other aircraft. Then you have the NOAA aircraft that goes around the storm. Then you have another Department of Commerce, what we call a 3D weather plane that goes inside the storm and takes a good look at the storm dynamics scientifically. We also have NASA aircrafts that also go into the storm and give us a good picture. Well, one of the things that happened in the year 2001 during Hurricane Umberto was we put all these aircrafts together and they flew a mission together to give us characteristics of the hurricane. Now we can finally model a hurricane and get the dynamics of the hurricane, just like you have a little car model of a regular car, and it kind of can give you various features of the storm itself. Now, these are the findings that we've had here recently dealing with storms. We've noticed over the past 32 years there's been a significant improvement in the track of hurricanes. Remember, we got the model, now we have to make the forecast. Well, we've lowered those track errors in the 72-hour time frame to about 53% better. We've gotten from an error of maybe 5,000 miles, down to about 200 miles in the 72-hour frame. So if we make a forecast 3 days from now, then you know that there's about a 200-mile error. And so forth with the 48-hour forecast, it goes from about 300 miles that we used to do years ago down to about 100, and so forth. In the 24-hour, we've made some improvements. So those are significant bits of information to let you know and how much confidence we have in the modeling. However, when you look at the intensity, there's a difference. Our capacity to forecast intensity is causing us some problems. We haven't made tremendous increases, but of course, we're going forth with trying to do our best. The Lord has given us some skills, but He hasn't given us everything. This is one of the tools that we use for hurricanes. We can go ahead and plot the location of the hurricanes, what the significant rings around the hurricane to give you storm force winds and how they extend out relative to the storm itself. It gives us a track. This is the error chart to show you what the track would be and how much error you'll have to the right or the left of the hurricane. Notice in 72 hours you would have a big variance across the Louisiana coastline. Now, I talked about the improvements in the 3-day frame. Well, we've gone out 5 days now experimentally to try to give a better picture for the planners so they could make their mission secure. Take, for instance, the military. They may have ships out there and you may have to move ships around. It takes about a little bit more than $1 million a day to move those ships around in the military. So we've given them a 5-day forecast to try to give them an estimate of where they could go, how far they could move out of harm's way in order to prepare for hurricanes. So that's shown some improvement. One major problem now, relative to the hurricanes, and I'm getting ready to wrap up here, is where is the next one going to hit? And we talk about a little bit about the fact that this is an El Nino year, so we should have a little bit less hurricanes than normal. However, it doesn't matter. It's where you are relative to the hurricanes. It could be Galveston. It could be New Orleans itself. It could be Miami Beach. It could be the Outer Banks of North Carolina. It could be Ocean City, Maryland. It could be Cape Cod, Maryland. It could be Long Island. Those are the various places along the coast, broad area, that we have to contend with relative to storms. So, my word to you is to make sure that you get prepared and get ready for the storms. And I'm going to try something on this next one. I don't know if it's going to work, and I don't think it is, but that's Hurricane Delaney. I think we're going to cut it off here. Thank you for having me. Get ready for the next portion of the Nuno's historical series. I enjoyed being a guest lecturer today, and hopefully I can see you in the future in another guest lecture series. Thank you.